Today we're going to be working on Leetcode question number 329, longest increasing path in a matrix. Given an m cross n matrix, integers matrix, return the length of the longest increasing path in matrix. For each cell you can either move in 4 directions, left, right, up or down. You may not move diagonally or move outside the boundary, meaning you won't wrap around from one side to another side. And again, you cannot definitely visit an element which you already have visited. Right, yep. So in this case it's gonna be 1 2 6 9 as shown, so the output is gonna be 4. The way we're gonna be doing it is like using the depth first search, and at the big, like, we gonna define directions. So we're gonna call it public static final int, and let's call it directions. This is basically going to the right would be 0 1, going to the left is gonna be 1 0, no, going down is gonna be 1 0, then going to the left is gonna be 0 minus 1, and going up would be minus 1 and then 0. Okay, once we have it, all we have to do is, like, basically there's gonna be a sanity check that if the matrix dot length is equal to 0, we just return 0. Okay, then we're gonna have our m equals to matrix dot length, and our n is gonna be matrix total number of columns, dot length. Okay, once we have it, we gonna use, in order to, like, more than a visited one, basically it's gonna act as two things. It's gonna act as a visited matrix, and also the value of that, like how many have you been to, like what's the answer last time you came across this index. So we're gonna call it cache, and the dimensions are gonna be m cross n. Okay, and initially our max is gonna be equal to 1. 1 is gonna be the minimum answer no matter what, unless you just have the there is no element in the matrix, and then that's gonna be 0. Okay, now we're gonna iterate int I equals to 0, I is less than m, I plus plus, and then our j is gonna be going from 0 to j is less than n, j plus plus. Okay, now once we have that, we're gonna say that we're gonna call DFS, depth first search function, and with all the values, and it's gonna return us an integer value, which is gonna be the length. For that, we're gonna be using matrix. We're gonna be sending in I, the current I and the j index, and also the m and the n and the cache. So basically we are sending him the total rows and the columns every single time, and the cache, so that if we already have calculated this point, just return the length of that I or j, don't recalculate it. And at the end we're gonna say math dot max between the max and the length, and in the end we're gonna be returning the max. Okay, now the last thing we need to do is to implement this DFS function. Let's call it public int DFS. It takes 2D array matrix, it takes an I, it takes a j, it takes an m, it takes an n, and a cache, right? Okay, once we have that, okay, what do we need to do? Once we have it, first thing we want to check if we have already calculated this index. So for that, for cache I j, if the value is not equal to 0, because everything was initialized as 0, we're just going to be returning that value. Okay, looking good so far. Now we're gonna again start with our max equals to 1, and then we're gonna go through all the directions and array direction and the directions. Okay, we're gonna calculate the next movement, so our next x and next y. So the next x is gonna be equal to I plus dir 0, and our y is gonna be equal to j plus dir 1. Oops, I think I pressed this insert. Okay, looking good. If we are out of bound, x is less than 0 or x is greater than equal to m, or y is less than 0 or y is greater than equal to n, if we're out of bound, or if the new one is not greater than the last one, right? If it is not an increasing, or the matrix of xy, the new one, is less than or equal to the matrix of the old one, ij. In all these cases, just continue, we don't want to process it. Like, yeah, it went out of bound, or it is not incrementing, we don't want to continue, we don't want to go in this direction, so just go to the next one. Okay, int now we're going to be calculating the length, so that would be 1 plus the dfs, because every single time we are incrementing by 1, dfs of matrix, and then again the x, y are the new i's and the j's, and the same m and n and the cache. Okay, that is would be the n, and the max is going to be math dot max of the max and the length. Okay, once we come out of this, we're gonna update our cache at the ith and the jth position with max, and then return the max. Looking good. And it passed all the test cases.